Hey everybody, welcome to my next tutorials on Android Framework components. And by the way, this is Dimple here. So in this particular tutorial, we will concentrate on Android Audio Framework. So before moving on, we will see what is this codec or decoder. Codec or decoder can be defined as a computer program or device which is able to encode or decode digital data stream or signal. For example, here we can see two components and codec contains two components, encoder and decoder. So encoder will encode the digital stream for transmission, for storage, as well as for encryption. And the same data is decoded at the other end for playback or editing purposes. For example, when we record a multimedia file in a raw state, it will be very huge. So this codec will compress that huge raw data into small sophisticated format for storage and transfer. Now, next we will see what is this Android audio architecture. Starting from our smartphones through which we invoke the entire process. So from our Android app, we request the application framework. So this application framework includes audio manager, media player or ringtone manager, which are high level classes which provide audio services to all the applications. So this application framework from this application framework, the requests are going to native media player with the help of JNI or Java native interface. So JNI is associated with Android.media package. It will call the lower level native code to access audio hardware. So JNI will connect application framework with C++ implementations. See, for example, all our application framework, we write it in Java. So this JNI helps in converting that Java written programs to their C++ implementations which are present in native media player. So the native framework will provide native equivalent to Android.media package. So the most frequently invoked native methods are located in Android Media Player.cpp files, which instantiates a C++ media player object for each new media file. Going to the next slide, we can see the communication between the native media player and the media service player happens through IPC, inter-process communication. So the instantiation of a media player service subsystem involves creation of media player service object. So once this media service player is ready, once it is up and running, and once it receives request from the native media player, a new media player service client is created for each request that manipulates media control. So for each and every request, a new client is created. So this slide depicts the entire Android architecture. All the requests from the media service player come to the component called Stagefright Media Player. Stagefright is a media playback engine at native level that has built-in software-based codecs for popular media formats. So this Stagefright has three components: extractor, awesome player, as well as OMX codec. So the media extractor, it involves appropriate data parsers in accordance with media type. So it will extract the data in the required format, for example MP, MPEG or MP3, etc. So then this awesome player sets communication between different components. So whatever parsed data is coming out of extractor, that will act as input to this awesome player, and this awesome player includes functionality like video captioning, connecting different audios and videos, providing sources with appropriate decoders, playing media, pausing media, starting, synchronizing, restarting media, everything. So to prepare playback, this awesome player will use OMX codec component to set up the decoders to use for each data source. So this OMX codec components will contain decoders, and we saw that the job of the decoder is to prepare for playback purposes. So using this OMX codec, final playback is prepared. So from this OMX codec, the output or the next control goes to the kernel driver, which will interact with the hardware and HAL layer implementation. So this was a brief detail about Android Audio architecture. Next, we will see one small example program in which we record an audio, we store it in a device in a particular file, and then play back that audio whenever required. So in this program, we can see that media recorder is a class. So this class is present at the framework layer, which will provide higher level services to your application. So here I'm creating an instance of media recorder. I'm creating an instance of media recorder, and then I'm setting the audio source, audio input source. In my case, I'm setting the audio source as microcontroller. Then I'm setting the audio output format here. For example, I'm setting it to 3GP. You can choose any format you need, like MPEG, MP3, any format for that matter. Here, for example, I'm setting it as 3GP, and whatever data I record, or sorry, whatever audio I record, it should go to an output file. So here I'm defining my output file. I'm storing my audio, whatever I record, in my myrecord.mp3 file format. So I'm getting permission to that particular file using environment.getExternal storage directory. Next, when I click on the start button, the audio player is preparing. So first, before starting our recording, we have to prepare it. So audio player.prepare will prepare the media player or media recorder. Next, we give audio player.start. So when we give this audio player.start, the awesome player will be initiated, and it will be idle until the user finishes recording or submits a new command. Then when I click on the stop button, the recording will be stopped and all the audio player will be released, and I'm making it to null again. So when I want to play it back again, I'm creating a new instance of media player. Previously we used media recorder, now we are using media player class, and using that m.start, which is where m is an object of media player, I can start my playback. So this was all about audio framework. Hope you all enjoyed it. Please stay tuned for other parts in this series. So see you in the next tutorials. Thank you.